MU, oh, vacation. I was going to say like some clubs or something. Okay. Here we go. We have 2 total vocab, and that's it. Not too bad. Let D denote a fixed line. A fixed line called the directrix. And then we're going to use big capital F to be the focus. And little e be a positive number called eccentricity. So these are the 3 variables we are using. Ready? I'm just defining variables, don't be scared. You already know what the directrix is. You already know what the focus is. The only new thing is your eccentricity. Definition, ready? A conic is a set of points. Let's call it P in the plane, because a lot of you gave me the same definition for ellipse and hyperbola. But in the ellipse, it was a set of points with a sum, right? What's an equal distance? And then in the hyperbola, it was the difference of the distances. So that's the difference between the 2 definitions. So for the conic is a set of points P in the plane such that the ratio of the distance from F to P. What's F again? Focus. Yeah, just a focus. Okay. Focus to point P to the distance from directrix, which is big D based on this definition, to that P equals E. Okay. That's verbally spelling out the definition of your conic in polar. Tell me what it said. Okay, would you agree that it says equals E? Yeah, okay. Let's write, then let's just write that in equations. How about E equals? It says a conic is a set of point P in the plane such that the ratio is what? Division. Okay, let's make a division bar. Beautiful.
Division bar.
Division, what's on the top? From what?
The numerator.
Yeah. The distance. We use little d for the distance. Distance from F, which is the focus, to this point P. The ratio of that's the numerator, to what? Another distance, right? The second distance from where to where? Yeah, see, not so bad. That equals to E. Now, if you know E, then you would know all of the shapes. Case number 1. If E is 1, this shape will be called a parabola. Number 2. If E is less than 1, this shape will be called an ellipse. Last case. Guess what it is? Hyperbola. So all of the shape is dependent on the E value, as you can see. Now, on number 2 and number 3, vocab 2, it says eccentricity E value of only the ellipse and the hyperbola. The reason is that on the ellipse and hyperbola, your A value is from where to where? center to one of the vertices, right? And then C values from, right. For the hyperbola, the variable is slightly different. So this definition is only for the ellipse and hyperbola. Ready? You can also find the E value using the ratio of C divided by A. Okay. Where, again, where C is the distance from center to where?
Okay.
Yep, distance from center to focus. And A is the distance. A, let's do that so you know that's not A is, okay? A is the distance from where to where?
Center to vertex.
That's right. Okay. Now, just later, just in case later, if we were to ask you to find different distances. Now, you were given earlier on vocab 1, E equals the distance from focus to the point divided by distance from directrix to a point. Is it possible for us to manipulate this algebraically and find the distance from the directrix to a point?
Yes.
What would that equal?
Distance from the focus to the point divided by.
That's right. Distance from the focus to the point divided by E. Okay. How about if we manipulate it again and want to find the difference from the focus to the point? Now what would that be? E times, yep, E times the distance from the directrix to the point. Okay. So just by manipulation. Okay, I know the two vocab, they look totally scary with crazy variables, but once we start to use them, it's going to look a lot better. Theorem, here we go. You got pole equations of a conic. The focus is going to be at the pole, and the lowercase variable e will be called eccentricity, or eccentricity. Okay. So you're going to have 4 different equations. First equation, it's in polar form. So you can have R equals E times P divided by 1 minus E times cosine of theta. Okay, so this first box I'm going to need to write small because I have a little bit more information to fill in. So this is a polar equation of a conic with the focus at the pole. And directrix is going to be perpendicular to the pole axis. At a distance p units to the left of the pole. It's our first description, so I want to make sure I write it all out. So when you read it, it's more well understood or more fluent. The next couple of description, we'll skip a few words. Okay. So we have E times P all over 1 minus E times cosine of theta. Then we can do the same thing, except now we can do 1 plus in the bottom. Okay. So again, it is going to be the polar equation of a conic with the focus at the pole and dot, dot, dot. Okay, and the directrix. We'll skip all of those first lines. And the directrix, for this particular one, is still perpendicular to polar axis at a distance p units Not to the left anymore. Guess what? P units, what direction? To the right, because it's a positive cosine. P units to the right. Over the pole. Yes?
So is it polar equation of conic with focus at a pole and directrix
Perpendicular to the polar axis.
at a distance of p units to the right of the...
Right, this particular directrix. Yep. This particular directrix will be P units to the left on the first one and P units to the right for the second one. Very good. So that's cosine. Let's do sine. 1 plus E sine of theta. So again, it's another polar equation of the conic with a focus at the pole still, and this time the directrix will be parallel. The directrix is parallel to polar axis at P units above the pole. So class, this is really just describing the position of opening, right? If the directrix is on the left, obviously you're opening on the right. If the directrix is on the right, you're opening on the left. If it's below, you're opening top. If it's top, you're opening low. It's just really telling you how it opens. Okay? All right, last one. R equals E times P, 1 minus E times sine of theta. Again, it's the polar equation of the conic with focus at the pole and directrix, dot, dot, dot. Directrix for this one is still what? Parallel to polar axis at P units below the pole. Okay. All right. Well, if this represents parabolas, ellipses, and hyperbola, how do I know which one's which? Use E. Okay. If the eccentricity is 1, what shape is that? Parabola. Parabola. I'm going to add in a description. The axis of symmetry is perpendicular to the directrix. It's just a fact, really. So this is not new. Would you guys agree that the axis of symmetry is always perpendicular to the directrix?
Yes.
Yeah, that's just not any positioning. It's just stating the fact. E is bigger than 1. What shape is this? High. Perla. Excuse me. Again, stating the facts. Transverse axis is perpendicular to the directrix. Just stating the fact. Nothing to be scared about. Then E is less than 1. My last shape is?
Ellipse.
Ellipse. In ellipse, we talk about major axis. Major axis is perpendicular to directrix. Okay. So example 1 is supposed to kind of lead us easily into graphing. So 1, we don't have to do any graphing. Identify the conic of each polar equation that it's representing below. Also give the position of the directrix. Okay, here we go. Number 1A, R equals 3 divided by 1 minus sine of theta. The standard format of sine is R equals E times P on the top, 1 minus E times sine of theta. Would you agree that's a standard format of your polar?
Yes.
Yes. To determine the shape, what do we need to know? E. Let's find E. What's E? E is 1. Look, this is already 1. This is 1. So that means this front number right here in front of sign should be 1. Okay? So E is 1. That means I can find out the shape. What shape is this?
Parabola.
Parabola. Perfect. I need to know P to decide where the directrix is located. Oh, you know it's 3? How do you know it's 3? Yeah, because on the top is E times P. And if E times P equals 3, then that means E is 1. That means P is 3. Now let's talk about the directrix of a 1 minus E sine of theta. Directrix is perpendicular to what? I'm sorry, parallel, you mean? Parallel. That's okay. Directrix parallel to polar axis. How many units? 3 units. What direction? 3 units below. Below the pole. Would you guys agree that if you know the directrix and you know your focus is at the pole, you should be able to locate the vertex? Let's repeat that statement one more time. If you know the directrix and you know the focus is at the pole, would you agree that you should be able to find the vertex? Where is the vertex in relationship to focus and directrix? Right smack center. Yeah, that's why directrix is important. Okay. Okay. B. This is cosine. So the standard format is R equals E times P divided by 1 minus E times cosine of theta. That's the standard equation. Can you guys see that the standard equation is always in the 1 minus E or 1 plus E of something? Your given equation is not 1 minus, so you have to do what? You have to factor it out. So you can have a 1 minus 1 cosine of theta. Okay. To put it in standard form, I need to get rid of the 3 in the front. So that means, can I multiply the bottom and top by 1/3? Sure. All right. So R equals, on the numerator, 1/3 divided by 1 minus cosine of theta. We need to find E. What's E? 1. So E equals 1. On the numerator, E times P equals 1/3, y'all. That means if E is 1, what's P?
1/3.
1/3. This allows us to state where the directrix would be from the pole. Similarly, what shape is this? Okay, for this particular case, it's still a parabola. It's a minus cosine, so directrix is parallel, perpendicular. Perpendicular to what? Polar axis. 1/3 units. Left or right? Left. Okay. Over of what? Pole, right? Okay, should we conclude here, or do you want to continue?
Let's continue.
Yeah, wherever we end, it's on the video, you only have example 2. So wherever we end on example 2, it's just where you're going to pick up on the video. Continue or stop? All right, let's keep on going. Okay. How much more time, though, do we have before I continue? Oh, then let's stop. I was going to cancel. Okay. Example 2, analyze each and graph it. All right. Is that in standard form? No, because it's not 1 plus or 1 minus. So we want to get it in standard form, which is E times P in the top, 1 plus e times sine of theta. So we want to rewrite this into 1 plus, okay? So r equals 12 stays on the top. What are you going to factor out? Of 4. So that's going to be 1 plus 2 sine of theta. Can I reduce, by the way? Can I divide this by 4 on top and bottom to get a smaller number?
Yeah.
Yep, so 1 equals, what's on the top? 3 divided by 1 plus 2 sine of theta. Okay. Is it possible to find e? Ah, e equals 2 right away. What shape is that?
Hyperbola.
You're going to be graphing hyperbola. Okay. Hyperbola. Perfect. E times p, y'all, equals what? 3. E times p equals 3. E is 2. Okay? So E is 2. Then what's p? Yeah, divides by 2, so 3 over 2. Although it doesn't say find the directrix, right? In a little bit, we'll analyze it and write that in. Oh, let's just write it in. Directrix is perpendicular, parallel. It's plus sign. So what is that? Parallel to polar axis. 1.5 units. What direction? Above the pole. All right. How do we graph this hyperbola? Carefully. Do you guys remember how to convert it to rectangular form? Oh, okay. All right, here it is. We'll take the reduced form. We're going to convert it to rectangular form. Let me remind you of something. R squared is always?
X squared plus y squared.
X is always? R cosine of theta. That means y is R sine of theta. These are the things you have to remember. Okay. Okay, so step number 1, can I multiply both sides by 1 plus 2 sine of theta to get rid of fractions? C, okay. So R times 1 plus 2 sine of theta equals 3. Can I distribute my R? Sure. So R plus 2 times R sine of theta equals 3. So far, so good. What's next? Yeah, what's this? Y. So, okay, so we can convert that to 2y equals 3 here. What's R? Radical. Okay, x squared plus y squared. Now what? We know it's a hyperbola, so we have to make sure it looks like a hyperbola so we can graph it. What's your next step? Hint. Move the 2y because you are about to square both sides. Okay. Move the 2y so we can square both sides. So this is x squared plus y squared equals 9. What's in the middle?
12.
Minus 12y plus 4y squared. What do you think we are going to do next?
Simple.
Complete the square. All right. I'm so glad you said completing the square. Okay. I would say x here. Would you agree that we would be moving 4y squared to the left?
Yeah.
That means I'm going to end up with negative what? 3y squared. We will also move the 12y to the left. That means I'm going to end up with positive 12y. We will leave the 9, so we're going to make it equal to 9. Sorry, it's frozen, so I can't erase the plus sign. My pen is frozen. There you go. All right. Equals 9. Completing the square. Here we go. Slowly. Take out the negative sign. Oh, take out negative 3. My bad. Take out -3. You're left with y squared. Space. What goes in the blank space? 4. Well, you add it to the left. You will be adding to the right, but is that perfect? No. That needs to be multiplied by?
3.
-3. Perfect. Good job. X squared minus 3, quantity. Y minus 2, close it up, equals a negative what? -3. Agree, disagree? Then remember, it has to equal to what? 1. So divide each and every term by a -3. That means I have to move my y in the front. Yes or no? Yes, because that's a positive now. Okay. I'm going to hold it right there before I go further. So this becomes a 1 here. The y is now a positive over 1 value minus x squared over 3. Would you guys agree with that equation?
Yeah.
We're going to hold right there because I don't want to start graphing and then the bell's going to ring. This is what you're going to pick up.